Hi, everybody. This is Arlo Gilbert, co-founder and CEO of Osano, a leading data privacy management platform. And you are listening to the Privacy Insider podcast. This show explores the past, present, and future of data privacy for privacy and business leaders alike, as well as anyone who wants to keep privacy top of mind. Hello, my name is Arlo Gilbert. I'm the founder of Osano, a leading data privacy company. Today, I'm your host on the Privacy Insider. We're joined today by Philip Rathle. Philip is the CTO at Neo4j. Neo4j is the leading dominant graph database. It's been downloaded hundreds of millions of times. It's used by 84 of the Fortune 100, and their last valuation was in excess of $2 billion. Philip has overseen the growth of this company from its early days. Philip, welcome to the show.
Thanks, Arlo. Pleasure to be here.
So, Philip, we have a lot of people on this show who represent the privacy side. We've had regulators, we've had technologists, we've had ethicists and philosophers. We've even had leaders of technology and politicians join us. But we've never really had a deep technical mind join us on this show before. And you're working on really interesting technology that has a lot of overlap with privacy and AI. And we were hoping today that we might learn a little bit about some of the technology that you're using and developing. But before we start with that, we always want to know, who are you? How did you get here? I mean, you're the CTO of Neo4j, which is arguably the world's most popular and dominant graph database. And by virtue of that engagement, I'm imagining that you've got your fingers on the pulse of a lot of things that are happening. So how did a guy like you get to this place in life?
It really started with, getting into, first job working in tech as a consultant, and then somehow stumbling into data very early on the data warehousing, but also the operational side. And, some of my early experiences with data within a few years into my career, I was doing data modeling and DBA work, and eventually got into solution architecture kind of roles where I was sitting somewhere between the business and the technology, which is where where I still like to be. And, and really seeing the power of data, even going back a couple of decades, and how, for example, I was brought in as part of a SWAT team to do some work at MCI back in the day, if you remember them. And probably those of you who are old enough like me remember getting lots of telemarketing calls from MCI. Well, it turns out they had this massive marketing engine that marketed 300 million households per month, which, by the way, is more households than exist in the United States, with lots of business implications around that, like people getting multiple calls, and so that was an introduction to data quality and the reputational impacts and technical cost. And then underneath that, there was this batch job that was part of it that took nightly batch job that took 28 hours to run. So like, all right, well, there's this whole realm of it's a non-starter for a nightly batch job to run 28 hours or even 24 hours. Like it probably should run maximum like 3 or 4 hours. Got very much into performance, scalability, but also data quality, and how ultimately the fuel for business capability becomes how well you understand your data. Another implementation I was involved with early on was building United Airlines' first customer 360 system back when they had outsourced their website to a third-party vendor who then owned the profile. And then they had their own, Mileage Plus system, but they also were coming up with like a initial WAP phone and IVR, and how do you tie these together? So again, there, from an operational standpoint, having systems infrastructure that would enable the business to treat customers as the same person, regardless of the touch point, with all the latest information, so that you're dealing with someone who just missed a flight, knowing that they just missed a flight, likewise on the analytics side for doing customer value, lifetime value calculations, and that kind of thing. So, lots. I fell into data really early on and stuck with it. Got into database tooling for about 7 years. Ended up heading up a product portfolio at a company called Embarcadero Technologies, which had and has one of the leading database modeling tools, ER Studio, along with a number of tools for DBAs and developers working with data and databases. And then, yeah, 14 years ago or so now, had an opportunity to pioneer the graph category as the first product hire and product leader at Neo4j.
So I'm curious about two things on that. First off, how did you end up getting connected with the Neo4j team? I mean, there's usually a story in the early startup days of, they weren't 1,000 people yet. They didn't have billions of dollars. What was that like?
There were 20 something people, and I met the founder. He was raising, Emil, who's still our CEO, raising for his Series A. But, as these things often happen, it was through the professional graph in this case. And a friend of mine who worked with me in product marketing um, happened to know the first CMO at Neo4j, who happened to know that the CEO was looking for a first product leader. 20 people, the product founder is still in charge of everything like product and engineering and so on. And, he's looking for someone to post Series A, hand off stewardship of the product and of the product vision to someone who, could lead that, and was also grounded in what the world was doing and needed of a database platform. Yeah, stumbled into it really just through knowing the right people at the right time.
That's amazing. It's always good fortune that turns out to be one of the predictors of amazing outcomes.
For
And
sure.
and when you talk about your background, I mean, it sounds like there was a lot of data involved in there. What is it about data that you love? Because there are a lot of ways that you could spend time as a technologist and product leader. Is it, is it the structure? Is it the connections? Is there something about data that pulled you versus, I don't know, going into, coding, and being a developer or things like that?
Yeah, I definitely did some amount of coding in my time, but to me, I studied chemical engineering because I loved physics and chemistry and math and and the challenge. And what I realized coming into software is, in the same way that you're flowing some materials through a set of reactors and crystallizers and distillation columns and whatever else, and you're transmuting these these chemicals and their physical properties inside of each step. That in the enterprise you have all these pipelines, and what all the programs and code is doing is it's effectively transmuting and operating on data. So I saw the purpose of code. Obviously, this is just my perspective, and you could argue the opposite. But in my mind, the purpose of the code and the applications and everything else was actually to move data through, so that you could then use that data to operate your business from like a store and retrieve OLTP standpoint, and to make better decisions, and then ultimately predictions. And we can get into AI from analytics. But I really saw it as the core essence of, where a lot of value then came from. Obviously, you need to marshal up your data into applications that then will be used by users and create great experiences and so on. That's definitely a part of it. And that's been the appeal to me of being in product management and technology more broadly. Um, and then as technology moved on and we got into the early innings of AI, data, what what previously was done as code got moved upstream and became a data problem. This is what like supervised machine learning is instead of creating rules or speculating, I'm actually going to move that up into a data problem. So the data thesis and perspective I had in some ways became strengthened by AI, and then strengthened even more so as we get into generative AI, where all the magic that language models are doing just comes out of being trained on massive amounts of data. Now, what we don't think about is that data is often curated. You've got companies like Scale AI and, and others who actually do all this manual labeling and so on. So it seems like it's just masses of uncurated data from the outside, but there's still, a little bit of very much of a garbage in, garbage out. Um, and so data still remains as or more important than ever more.
Well, let's talk about data. It was 2013, 2014. I was in San Francisco, and there was a meetup at the Medium headquarters in that triangular building. And I remember going there because I saw that there was a meetup about graph databases, and I was really curious about graph databases. This was a new technology, and there was a lot of question about whether graph as a technology was actually even a real database and a real thing that people would want to use in a commercial scalable way.
Yeah.
And I believe that early on, companies like Medium were some of the big early adopters of that technology. But a lot of people hear the word graph and their mind goes to, the paper they had in school. You had your graph paper,
Yeah.
or they heard about Facebook building a social graph to monitor all of us. And I thought it would be really helpful if you might take our audience through kind of a 101 of what is a graph database exactly, and how does that work? Because I think most people understand broad concept, at least conceptually, they understand what a tabular database is or a relationship database is, right? It's like an Excel spreadsheet. And if you're familiar with pivot tables, you kind of understand joins. But beyond that, graphs are way more complicated. And I think it would be helpful to understand that.
Yeah. And my perspective is they're not more complicated. They're simpler, but let me get to it and explain why. The idea with Neo4j and what would kind of give birth to the technology and the idea is a lot of the world just shows up as, there are systems in the world that we need our software to be able to understand. And this is even more true of AI. And those systems, how do they show up? Well, you could say that what gave birth to relational databases was the need for business process automation. Um, and then what's the data problem underlying business process automation? I have data in warehouses and filing cabinets in paper forms. So paper forms have the characteristic of being um, human generated. They're pretty straightforward. You can easily come up with a set of rules to break them apart, remove your redundancy. These are all the normalization rules, and then to rehydrate it back into, some form or subset of the form when I'm working through my system. So that's a bit oversimplified, but not far from the truth. The increasingly, as we've mastered that and moved on to managing, having to deal with these complex dynamic, world of business where everything's interconnected, and with the build applications that do, digital transformation and AI, and I need to deal with networks of people, networks of computers, networks of spread of ideas, of influence, of geopolitics, of networks of payments, networks of biology, networks of ecology. A lot of things in the world show up as networks. Likewise, you have networks that are maybe more like up and down, hierarchically shaped or shaped like trees. This is like an HR hierarchy, which, by the way, is not strictly top down. It is from a reporting structure perspective, but in terms of the way the org actually operates, and I report into a project, and maybe a project manager there, and I have a mentor, and then there's the historical dimension, and then there's my skills all around me, and so on and so forth. But you could say that's, broadly hierarchical. Permissions, asset ownership, supply chain. These things are all like real world systems, digital world systems that are more hierarchical. And then you have paths and journeys through that customer journey, patient journey. And so the observation that our founders had, and that I really resonated with me as a thesis, is look, like we're taking all this stuff that's shaped like networks and hierarchies and stuffing into tables. And there's a huge impedance mismatch, which is a jargon for there's a great distance between the way the data is shaped and shows up in the real world, and even the way that a business person will like whiteboard their domain. They always do that as like circles and lines that are connecting each other, which is a graph. And they're not going to say like, here's my supply chain and like draw out tables and then like join tables and recursive joins. And that's just not how we intuit data. It's not how it naturally shows up. Um, Not that you can't put it into a relational database. Anything you can put into a graph, you can put into a relational database and vice versa. And, but the observation was for a world of business that's fast moving, where I don't know from one minute to the next what problem I'm going to need to solve next to be competitive, and where I'm next going to get, and what piece of data is going to give me the most value. So you want a model where the distance between the business conception and a developer's way a developer works with the data is has is as little distance as possible between that and the way the data actually lives in the data structures in the database that's managing it, as well as to have a model where ideally I should be able to add to my data without going through this whole schema migration exercise and spend, multiple weeks or months, getting data modelers into a room to figure out how to adapt the model, and then doing a whole development effort around, how do I change my application now that my schema has changed? So schema flexibility is another core principle here. That is, a part of the core implementation in Neo4j and in many graph databases. Of course, you have an option of then after the fact adding constraints once you understand the data and want to, implement those at a lower level. And then also having a query language that is based on understanding how things are connecting. So expressing connectivity in a query language, so that instead of having like, 50, 100 line queries that are doing 15-way joins in order to do, some supply chain query that's multiple levels out, or some social, arbitrary, what Kevin Bacon type queries, which are actually useful in many business contexts, of what's the shortest path between these two points in the network. Being able to express those queries and then being able to run them very efficiently. And those are all the, let's say, core ingredients of what make graph databases different and also useful. So relational databases are super useful and obviously by far, by 10x margin, the most commonly deployed with respect to all other database technologies combined. Notwithstanding, any AI application that you build today, you're going to want to, and I'm sure we'll get into this, but deal with fast moving data, cut across the silos, have a language that both humans and models and AI agents can easily generate and express queries in. And it turns out the graph database checks all of those boxes, particularly the way Neo4j has implemented it. So think of it as to bubble up, a database management system built from the ground up for contemporary hardware. So where it's memory abundant, memory's fairly cheap, very fast storage substrate rather than spinning disk. And that is designed to store and work with and analyze, but also to be the real-time system behind agents for doing retrievals in worlds where you've got one or more of these complex, kinds of real-world systems that show up as networks.
So then the takeaway and what I'm hearing is that relational databases, as we think about them, I mean, at their core, they weren't really designed for relationships. They were designed for storing tabular data, and relationships were
Like there's a huge irony there. Yeah.
right. And whereas graph databases actually were built by design to be about connecting the dots between different things.
That's right. Yeah. The relationship is a first class object in the database. And what that technically translates into is I have nodes, which I can use to represent things. And I have relationships, which is like it's what it sounds like. It's how does this thing relate to that thing? And relationships have a type, they have a direction, they can have a number of properties. So you can have attribution of relationships, which is great, like from a start date, end date, level of certainty if I'm dealing with identity, and so on and so forth. And this model has been, let's say, blessed and by the International Standards Organization and the same body that came up with the SQL standard um, nearly 40 years ago. Like SQL 86 was adopted by ISO in 87. Um, there literally is no other, for 30 plus years, there was no other ISO standard database model or language to go with it up until the graph model came around. And now there's something called GQual, which for all intents and purposes is more or less the same as Neo4j Cipher query language, which is was already the de facto language for graph databases. So it's something that has, you could say, your generational seal of approval from the key standards body that governs database standards.
That's great. Well, I'd love to talk about the privacy implications of that. But before we talk about that, I'm curious with the growth of generative AI and all of this need to do lots of disparate retrievals. I'm assuming that this has been a bit of a renaissance for Neo4j. I mean, it was already a fast
Yeah.
growing company, but has this AI wave really had a significant impact on technology decisions and customer buying behavior? Are you seeing a lot of AI first buyers?
It's been a massive tailwind, and of course, whenever there's a big generational platform shift like this, first of all, the pendulum swings over, and everyone starts using just the one piece of new technology to solve everything. So LLMs, and then very quickly, you discover, all right, what's the right mix of new technologies? So like vector embeddings is another one with other existing technologies like graph databases um, to let's say balance and make create a 1 + 1 = 10, let's say, in the case of LLMs, vectors, and graphs. So it's the buying behavior has definitely shifted, and I think for everyone in enterprise tech, very heavily in the direction of AI. And lucky for us, the technology that we built happens to solve really the top problems that you end up with in AI applications um, when not using graphs, which are hallucinations, lack of explainability, lack of, let's say, data governance slash discernment slash judgment of knowing what data is appropriate to use for what purpose, and then being able to have access to explicit context.
So we talk about AI, and let's shift over to privacy because that is a big piece of anything that you build these days. I mean, if you're going to put the data in, then you now have all these obligations under various regulatory regimes that require you to be able to get the data out, to be able to cleanse it, to be able to control access to it. How are graph databases and Neo4j in particular, how do those contribute to privacy, and how can privacy professionals think about this technology that for a lot of people feels very abstract, right? If you're not a database person, then you're probably not super familiar with it, and anything new or anything unpredictable obviously creates fear in the mind of people who are involved in risk. So how do people manage to govern a Neo4j instance? How do they implement privacy controls on a Neo4j instance?
Let me start with customer 360 and unifying silos is a way to get into the answer to your question. One one of the most common use cases that we've had over the years is um, how do you solve the problem, which every company has, that you have each department, each division has one or more silos, usually many, many silos, um, that are either internally built applications or, some third-party app. And when you're engaging with the customer, what we all know as customers is we want companies to take into account the entirety of our relationship across all channels, across all the identities I've used, across all the channels, phone, email, text, etc., social media, and across all the different departments and lines of business. And so there's always been this problem of, how do you get to a single identity? And where Neo4j's used a lot is to say, let's create a graph that has all the different identities, all the other identities, and how they relate to each other. Because you know what those are. You might have to go hunting in a bunch of different systems to pull it up. But then you can put those into a graph where I can say, here are all the different aliases for what ultimately is one customer, have a relationship there. And then for each alias, have a relationship with all the different identities, multiple email addresses that people have used, roll those up to households. And this very messy structure that's really problematic to deal with in relational databases becomes actually very easy to deal with in the graph. And then from that point, you can put the graph behind like a service layer that will call out, spider across the graph, figure out what the identity is, and then go. And if there's some payload you need to grab an existing system, you can all do that. And this ends up being a happy medium between the two extremes, neither of which works. One is let's just federate absolutely everything, which doesn't work. Or the other is let's create one system to rule them all. And, as the meme goes, then, if you had 14 systems and you create the ones who rule them all, then you just have 15 systems at the end of it. And so what does that mean for privacy? So for privacy, there are things that I want as a consumer that you could say almost are in the opposite direction of privacy, but I want the company to know all the things about them that I've told them that I expect them to know. On the other hand, I want to be able to make sure that the company is not using information in ways that I don't want it to, marketing opt-out and whatnot. And so by having this unified view that sits over and straddles your existing systems, you can then make sure that if there's a marketing opt-out over here, that bubbles up appropriately, and then isn't over-implemented in cases where maybe I want to opt out of certain things, but I really, really am interested in getting information about other things. Another thing you can do in the graph is there's information which a customer's disclosed. There's also information which you gather by virtue of their activity, which might end up in web logs and so on, where the customer hasn't explicitly identified themselves, but I might know who the person is, or I might know if they haven't yet disclosed who they are, I might know that all this activity adds up to a certain individual based on, looking at cookies, trackers, MAC addresses, IP addresses, and so on and so forth, and resolving those in some way. So obviously there are respectful and appropriate and legal ways to do this. But for me, it's convenient as a consumer, if as I'm engaging with a website multiple times, that they use what they know of my activity and serve up more and more useful information. And they don't need to know my name to do that. And the kinds of things that you can do with graphs on the analytics side are to take all these breadcrumbs, do some fancy analytics, come up with a suspected identity, use it for marketing. And we've seen companies get literally as high as like 600% uplift in engagement, which is completely unheard of in marketing world, where usually like low single digits is the norm for a successful marketing campaign by using graphs in this way on the analytics side.
So when you use the graph in that manner, that's being used, it helps to serve the end user, but it largely is helping the business. And when you think about the ability for a consumer to opt out, to delete, to redact their information, we call those the kindergarten rules of data privacy, right? If you want something from somebody, ask permission. If they want it back, give it back to them. And if they want to know where you're keeping it, be honest. Would it be fair to say that with a graph database, it's a lot easier to be able to identify, here's the information I have about you, for the purpose of reporting out, hey, I happen to have information about your buying activity here. I might have some behavioral activity here. And because it's all in a similar graph or it's connected, it's far easier for me to be able to surface the answer to what data do you store about me?
Yeah, that's right. And that comes up in there are two situations where you need to do that. One is people exercising the right to know when information is being stored. And then the second is right to be forgotten. And these both can be very expensive exercises if you don't have the right data infrastructure. And if you have a graph, then you can essentially have the structure through which you can easily like just work your way down the graph, just follow the dots literally, and follow the path into what data is stored at different levels. So that's definitely a use is responding to those requests in a way that's faster and, let's say in line with compliance timelines and faster for the customer and so on, but is way, 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 way cheaper. Now, I won't say that that's necessarily the highest value use. I think the higher, but it's, a super, yeah, is one of the value added uses. I'd say the highest value is making sure that you are using your data appropriately across channels based on what customers have requested, respecting, this is less privacy, but kind of in the same ballpark of what enterprises need to do, respect the organizational firewalls. So in banking, for example, the investment bank can't use certain information from corporate banking, for, regulatory and anti-competitive reasons. But it's the implementation is the same, is understanding what data at a fine grained level uh, can and cannot be used by what party for what purpose for what person.
Now, conversely, so those are great examples of, the pros of the graph. So, marketing teams can quickly get better uplift through better identification of properties and users. Sounds like there's some real pros to the privacy side of being able to do the same thing for the purpose of understanding what you store about me. What are the downsides when we think about graph databases? Again, I come back to this Facebook era where all we heard about was the knowledge graph, and so the word graph itself has some connotations around societal profiling and things like that. Are there any downsides or any challenges that you think graphs introduce into the privacy equation?
Um, I don't see downsides insofar as good actors using the technology as a tool, because what you can do is actually very rich. And I'll add one more capability that I missed is you can add weights to the relationships in the graph that reflect your level of certainty that this person is this identity, or this is this other identity, or this thing happened or this didn't happen. Um, so that could do a very, very rich set of tools. Then what the risks become is bad actors using this technology, which then means you need to defend against it. So, there's this saying on the infosec perspective, cybersecurity, that I was coined by someone at Microsoft years ago, which is attackers think in graphs. And so if your defender is thinking in lists or tables, then you're at a disadvantage, like it's, bringing, I don't know, a knife to a gunfight kind of thing. Um, and so what are some of those things? Uh, People who are doing, again, this is outside the realm of privacy, but I think the listeners will get the analogy. What is money laundering? Money laundering is nothing but sending data from multiple places to one through many intermediaries, and taking advantage of the fact that the systems that most companies have, at least up until pretty recently, knew nothing about being able to, understand paths across multiple intermediaries. And so that ends up being a big gaping hole for someone who takes a graph perspective on things. Um, Likewise, from a privacy perspective, um, a good example is blockchains like the Bitcoin blockchain, for example, where everything looks anonymous. Everything is public. All the transactions between wallets are public. Of course, the average person doesn't know who these wallets belong to, but the reality is you could have a million transactions and they're all anonymous, but then the second you need to pull money out of a financial institution. Your account's been KYC'd, and all it takes is that one link to tie you back. And now it can spider through the graph, and all those million transactions become very well known and understood.
Fair enough. So graphs give you superpowers and you can choose to use them for good or for evil. And it does sound to me like the scary part of a well orchestrated graph is getting into the hands of a government who now all of a sudden can explore my shopping habits and who I talked to and how I voted in the last election and what I said on social media. And so there are definitely some scary outcomes. It's not necessarily the graph database itself that caused that, but the graph database does enable that discovery at a new level.
That's a good thing for people to keep in mind, because to the degree that our personal information, our customers, our families is exposed in the public world, you can have an entire graph of social activity, and that's in its walled garden until until you have just the one link that um, connects it into some other data set. And now all of a sudden I know all this additional information. So the, the positive view when you're using this technology for good is that's amazing from the perspective of data network effects, and actually use case network effects, which is a term I came up with just observing that, if I solve for fraud detection, I might have most of the data that I need to do better recommendations and then anti-money laundering and entirely unrelated things. This is the beauty and power of the graph. On the other hand, what it means is things that you have probably assumed, and I've probably assumed up until now, that remain in a certain domain and can't be connected, can very, very easily get stitched together and used. And so activities that seem very, very remote end up being um, uh, and end up being very transparent to companies. So one example is, there's this ongoing debate of, are my iPhones and my apps on my iPhone listening to me? Because fake Facebook just, served up this ad, and it's exactly what I was talking about over dinner last night. And um, one of the techniques that companies like Facebook use is, okay, let's assume they're not listening on the phone, which supposedly they're not, um, is they know based on location sharing information that I was at dinner with the other people who were at the table. And if one of those people during dinner searches for a particular thing, then all the people who had dinner presumably are good to target with that particular thing, especially if that thing is a product that is an advertiser. So that is 100% happening. And that's something that listeners can take advantage of and guard themselves against as appropriate.
That's right. We always joke in my house when we talk about something in public or in front of one of our smart devices that, our ads are going to change real soon.
Yeah.
So as we think about the world of technology, do you hear much? I mean, there's a little while where privacy was really a top topic for a couple of years. It was in the news constantly. A lot of that came out of the Cambridge Analytica scandal. Do you feel like I mean, and you're deep in the heart of Silicon Valley, building a very powerful tech company. Do you feel like privacy is something that is being considered by many technologists? Is it being kind of put off for another day? How does that conversation rise to you?
I'd say it's somewhere in between. It's a really big deal in Europe. In fact, last year I was on a panel at Viva Tech with the Hunter Tallis, who's chair of the EU Data Protection Board. And, and AI is a big area of concern because the assumption, I think both rightly and wrongly, is that every model is getting trained on everybody's information. I think the nuance there is foundation models have access to a certain amount of things, and then companies aren't necessarily training their data in models or trying to trying to solve privacy sensitive problems in that particular way. But there's definitely the fear of this among regulators and among among the populace, and so the answer from that perspective is yes, very top of mind. Um, I think where it becomes top of mind among execs that I've met with is, um, if you do, one of the ways that you could get models to understand your business more is to train them on your data. But then if you're training them on your sensitive employee data or sensitive customer data, then anything the model's been trained on is fair game. And so people can easily use this to deliberately go and mine information about other people, and violate privacy laws and norms. Um, and so, therefore the model isn't the right place to do it in. But a lot of the rhetoric from, the foundation model providers kind of suggests that, well, I should just trust the model and it'll do the right thing. Um, and so to me, the counterbalance to that is, don't trust the model with everything. Like, look, we do have technology that can provide fine-grained access controls. Um, and in the graph, you have very fine-grained access control, down to property level, which is kind of like column level, um, as well as controlling whether a relationship can be traversed or not. So knowing that these two things are connected versus not, or knowing things about the relationship, or even down to, is this individual document, should it be accessible to a person based on, say, their clearance level versus um, the classification level of a particular document. So we definitely have tools to do this. Those tools don't exist at all in the LMs themselves, and that's fine. That's just how enterprise tech has always worked, is let's use a combination of technologies, and AI therefore becomes a composition problem of what's the right set of technologies to use and how do I delegate my different concerns. So graphs, play the role of, in cases where I need more accuracy or even 100% accurate and explainable answer that can respect all the different privacy rules. Graphs are super well suited to that when used as a knowledge layer that works as part of an AI system.
Yeah, it's interesting. We hear the fears about AI traversing our data, and it's a conundrum because in some ways these LLMs are capable of far more than we might assume they can do. But at the same time, we tend to ascribe a lot of power to these models, assuming that they have tools and data and capabilities. Not and the general public often doesn't realize that when you talk to Chat GPT on your consumer app, you're not just talking to the model. You're talking to a model that is armed with access to lots of different things.
Mhm.
And
Yeah,
so the model itself isn't the dangerous thing any more than the person is the dangerous thing. It's what does that model do, and what did the people who decided to use the model, what did they give that model access to?
100%. Yeah. Model was used tools, and the foundation model providers in their consumer products like ChatGPT, Gemini, Claude, and so on, Perplexity, can make call outs. They can make call outs to the web. Of course, in enterprise context, they can call out to tools via MCP, and that can include graph databases or any database for that matter, any microservice, and you name it.
Well, we've talked a lot about privacy on this show and a lot about graph databases. And I'm curious, we all support data privacy and we try our best to adhere to best practices. The graph database sounds like a powerful way to be able to exert some controls with those governance controls you were talking about. But sometimes it's a case of do as I say, not as I do. Is there anything that you have or any behaviors that you engage in that maybe don't live up to the best privacy practices in the world that you're willing to confess to us today?
Sure. So I have a couple, but so one, of course, is recognizing that when you're not paying for the product, you are the product. And, this is all the different social media platforms and, um, being judicious there. But I'll call it the one that actually impacts my life more viscerally, which is giving out my phone number because I have a cell phone. I just have one. I use it for business and personal. Um, and I travel a lot. And early on, I had, business cards that I would give out very liberally that had my phone number on them. And those would end up in some database, and I'd end up with, many, many calls per day from vendors selling all kinds of just random things to me, at any time of day or night, because, I'll be in Sydney expecting a call from a driver at 5 a.m. as I'm trying to get to the airport. And it turns out it's someone from the Bay Area trying to sell me some router or, some random thing. And I've still not learned my lesson and, taken the time to work out a, set of virtual numbers that I, some for one-time use and not give them out at conferences. So I'm definitely behind there. If anyone has any good tips, please reach out to me.
Just don't reach out by phone.
Just don't reach out by phone. No, actually, this call I would welcome.
Yeah, and it's funny. You mentioned the phone, and it immediately takes me back to the examples that you're using of, we know all this information about you here, we know all this information about you here, and it just takes one piece of knowledge to be able to connect those. And that phone number might be one of those pieces.
100%.
Well, Philip, thank you very much for joining. And folks, if you'd like to learn more about graph databases, I'd encourage you to go over to neo4j.com. That's NEO, the number 4j.com. And on there, they have some great documents. Philip has been part of building up a thing called the Graph Rag Manifesto, and they also have a Graph Academy there. I would encourage everybody, even if you're not intending to use a graph database, this is a seminal technology that has taken over our planet in many places that you don't realize it. And having an understanding of this technology is going to be critical to being able to succeed as a privacy and governance professional if you're responsible for making sure that people govern these databases appropriately. So, Philip, thank you for joining us today. This has been an illuminating conversation.
It's been a pleasure, Arlo.
Thank you for listening to this episode of the Privacy Insider Podcast. You can find a full transcript of this episode and any show notes at osano.com. That's www.osano.com. And while you're there, get access to an excerpt of my book, The Privacy Insider: How to Embrace Data Privacy and Join the Next Wave of Trusted Brands, which is now available on Amazon for purchase. Until next month, take care. And remember, data privacy is a fundamental human right, y'all.